Question number 1 starts us off with some information that is very convenient for slope-intercept form. Slope-intercept form being y equals mx plus b. And if you recall, the titles for m and b are slope and y-intercept. So we can see that we are given the slope right here, and we're given the y-intercept right there. So all we have to do is put those in their appropriate locations, and we end up with y equals negative 2/7. X still needs to be there, and then plus 8 for the y-intercept. That's all we have to do on question number 1. Question number 2 gives us a graph. We can still use slope-intercept form, y equals mx plus b, but we have to do a little bit of work here. I can see my y-intercept down there at 0, -3, but we need to do our slope by going up and over to find the rise and the run for the slope. So we count 1, 2, 3, 4. It's a positive 4 because we went up. And we count 1, 2, 3, 4. It's a positive 4 again because we went to the right. Now, slope is a fraction. Rise over run is supposed to help us remember which one goes where. The 4 up and down right here is our rise, and the 4 to the right here is our run. Now it's not typical that those two are the same numbers, so you'll need to make sure that rise is up and down and run is side to side. We simplify this when we can. 4 divided by 4 is 1, so I'm going to write my slope just as 1. So m will be 1x plus our y-intercept there is at -3. This can be simplified. So we have y equals 1x is the same as writing x. You could write it either way. And adding a negative right here is the same thing as subtracting 3. So you'll typically see this written this way, although this way is mathematically acceptable, so I would give you credit either way. Question number 3 gives us a couple of points. We don't have a graph. So if you like to use the graph, that's fine. If you can do it otherwise, that's great too. But our first point is 1, 2, 3, 4, 5, -3. So at 5, -3, we have our first point. And then 0, -1 would be right there. So we've got this line here sloping downwards. And we're going to the right and down. So from 0 to 5, our total is 5 to the right, and from -1 to -3, that's what we're looking at here, we go down by 2. So we have our rise and our run. If we do rise over run like we did on the last one, then this -2 is our rise, and the run is +5. And this does not reduce any further, but typically you'll see that written as -2 over 5 with the negative out front of the whole number. Either way is fine. We can see our y-intercept happens right here, but we can also recognize it here from the fact that our x is 0. So either way you can find the y-intercept, it's at -1. So again, we get y equals mx plus b. We know our slope, and we now know our y-intercept. So putting those in the equation, we have y equals -2/5 for our slope, x, and our y-intercept is -1, so I'm just going to go ahead and write -1 to start with instead of adding the negative and then changing it to subtraction. On question number 4, we need to know function notation here. Now I'm going to write these as an ordered pair, and we can see that f of x, our function notation, that x value has been replaced with the -7 right here. So our x value for this top equation is -7, and f of -7 is just another name for y, so it's like saying our y value is -1. So that goes right here for -1. And then this bottom equation, same thing. We look at that, there's our x value there inside the parentheses. That would be 0. And our y value over here on the right is -4. So we have those two ordered pairs. If you can read these two equations without writing the ordered pair, that's great. If it helps to write the ordered pair, that's great too. Either way is fine. Now we can graph both of these, so we get negative 1, 2, 3, 4, 5, 6, 7, and negative 1 for our first point. And then 0, negative 4 is right there on the y-axis, so we're sloping downwards again. Alright, how far do we go to the right and how far do we go down? So we are at negative 7 and we go all the way over here to 0, so that's a run of 7. We're going to the right, so it's positive. And then our y values go from negative 1 to negative 4, so we're going down by a total of 3. Now I like to use these numbers instead of my graph. You can see that this line right here doesn't match up with the negative 1 very nicely. So the fact that I have those numbers there, the negative 1 and the negative 4, and we can see them up here in our ordered pairs as well, helps us to know that we're going down by 3. So if you draw it on a grid, it'll probably be a little bit more accurate than my graph by hand. So we now have our rise and our run. Rise over run will get us negative 3 for our rise and 7 for our run. So we now have our slope, and we can see our y-intercept here at negative 4. We can also see it again with the ordered pair right there. So we now have all the information we need. Y equals negative 3/7 x minus 4. And we're finished. This last question right here asks us to write a linear model, or in other words, we're going to write an equation that represents the cost of tuition as a function of the number of years. So if we were to graph this, then our tuition would go on our y-axis and the year would go on our x-axis. We can see some information right here. Year 2000, college cost, the average cost for tuition was $14,000. And then in 2005, the average cost was $16,000. Now, this line right here, hint, the year 2000 is year 0, is going to make our work a lot easier, because if I take this ordered pair, I say the year 2000 got us a tuition of $14,000, then that is going to be a really, really awkward point to graph. So instead of year 2000, I am going to call that year 0. And when we renumber that, we just need to remember, okay, 2005 is not going to be written as 2005 anymore. Since 2000 was the year 0, 2005 would become the year 5. And we know that in that year it was 16,000, so we were given that. Alright, we now have 2 points to graph. So 0, I'm just going to write a 14 here for 14,000. Then we go over to 1, 2, 3, 4, 5, and we're up to 16,000. So our college tuition, we can see, is increasing that direction. So now we need to find our rise and our run. Rise and run. And I'm not going to count at all, I'm just going to use these two numbers. We went from 14,000 to 16,000. That means that we went up by a total of 2,000. So our rise is 2,000. And our run from here to here went over by 5 years. So our run is 5. So we end up with 2,000 divided by 5. That divides nicely, so we're just going to rewrite that as 400 as our slope. So that will be the simplified slope. Alright, let's clean this up a little bit. We know from our graph and from this ordered pair right here that our y-intercept is 14,000. So now we are ready to write our equation. We say y equals, our slope is 400. So we have 400x plus our y-intercept is 14,000. And that gets us our equation. Now we're off to the next part. This asks us to use this model. We're going to use the equation to predict the college tuition cost in 2010. Now we have to remember, since 2000 was the year 0, 2010 is going to be the year 10. So when we plug this into our equation right there, we're going to have to remember to plug in a 10 instead of the number 2010. Well, when we do that, let's go ahead and write that out. It looks like y equals 400 times 10 plus 14,000. And 400 times 10 will get us 4,000. So 4,000 plus 14,000. And let's finish this out by saying, adding those together, and we end up with 18,000. So the prediction for our college tuition cost will end up being 18,000. And we're finished with this question. Thank you very much for watching, and good luck.